Ask My Instructor 14.4.43. Find the average z-coordinate of points in a hemisphere of radius 11 centered at the origin with its base in the xy plane. The average value of a function of three variables is found by integrating the function over the solid of interest and dividing by the volume of the solid. That is, the average value of a function f over a solid D is 1 over the volume of D times the integral of f over D. In our problem, we are looking for the average z-coordinate of points in a hemisphere of radius 11 centered at the origin with its base in the xy plane. So D is the hemisphere and f is equal to the function z. Since a hemisphere of radius 11 has volume 1/2, 4/3 pi 11 cubed, the average formula becomes 3 over 2,662 pi times the integral of z over the region D. Find the bounds of integration. The region D is a hemisphere of radius 11 centered at the origin. We will start by looking at the sphere of radius 11. A sphere of radius 11 centered at the origin is given by the equation x squared plus y squared plus z squared equals 11 squared. If we integrate first with respect to z while keeping x and y fixed, then z ranges from the xy plane to the surface of the hemisphere. That is, z is between 0 and the positive square root of 11 squared minus the quantity x squared plus y squared. Keep x and y fixed. Let z range from the xy plane to the surface of the hemisphere. The limits of integration for the middle and outer integrals must cover the region R in the xy plane. In the xy plane, z equals 0, and so x squared plus y squared plus z squared equals 11 squared becomes simply x squared plus y squared equals 11 squared. For the middle integral, keep x fixed and let y range from the bottom of the circle through the x-axis to the top of the circle. For the outer integral, let x vary from negative 11 to positive 11. So integrating first with respect to z, then integrating with respect to y, and lastly x, the bounds of integration are given here. And so our integral becomes this triple integral. Integrate first with respect to z. Antiderivative of z is z squared over 2. Do the evaluation at the bounds and simplify. Check your work. Here is where I recommend that we switch over to polar coordinates. In the xy plane, we are integrating over the region x squared plus y squared is less than or equal to 11 squared. That is, of course, a circle centered at the origin with radius 11. It's quite easy to describe this in polar coordinates. R is going to go from 0 to 11, and theta is going to go from 0 to 2 pi. So let's make the switch to polar, and do not forget the extra factor of r required in the switch. So of course the bounds, r is going from 0 to 11, theta is going from 0 to 2 pi. The quantity x squared plus y squared becomes r squared. Distribute the r and then integrate with respect to r. Evaluate. Check your work here. And now we're ready to integrate with respect to theta. Our last step is to simplify. And we get 33 over 8. The average z-coordinate of points in a hemisphere of radius 11 centered at the origin with its base in the xy plane is 33 over 8. Now if you write that as 3/8 times 11, you can see that we go 3/8 of the way from the plane to the top of the hemisphere. Take care and have a great day.